there. Somewhere around here I have the mobile web Mobi product from Match.com. Today I'm going through a very nice presentation from a conference in Berlin, and a very good French Google developer advocate put this together, and we're just going to benefit from it. This is Martin Gorner, Animate to HTML5. He has this on YouTube, but he speaks entirely in French, so I'll be able to answer questions as we go along, and also present it in English.
So the slides in French, or?
No, fortunately not.
I'll translate for you.
Oh. Okay. So as an overview, we're going to cover the CSS3 animation techniques where you define properties and the browser tweens them on DOM elements. SVG, which is really, really cool. I'm actually hoping to get a speaker here to go in depth with that, but I saw at a conference recently. Was anyone here at Front Porch I/O? Yeah, so SVG strikes back. I'm going to see if we can bring that to this group. This covers that, as well as animating within SVG and using some properties where you can do keyframes. This covers 2D Canvas, WebGL with Three.js, and then a very bleeding edge technique called CSS shaders, where you actually put on GLSL shaders to distort DOM elements. Think page curls and things like that, but I'll get into that. So the first thing, who here is already familiar with CSS3 transitions and uses them for front-end work? So some of the headaches around that are prefixes and things, but you can get around that with Sass, mix-ins and things to automate some of that. But you see in this example, we have the WebKit prefixes on everything. And so you can just set up a JavaScript event. Well, essentially you have, this is just plain CSS. You've got the properties, and you specified that we wanted to change certain of those properties over 1 second from a position of 0 pixels to 500 pixels and a rotation of 0 to 360. And just by saying all that, when you change those properties on the DOM element, the browser will tween and change everything in between them for you very nicely. This is the 2D flavor of that. You can also define keyframed animations. So in this case, we're defining a set of keyframes where we're starting on one edge at one scale. Then we go to the left and shrink slightly and rotate, and then go to the far left and expand slightly and rotate the other direction. And so it's just playing with these 3 positions over and over again. And that's CSS keyframes for you. And you just apply it to your actual DOM element, specifying which thing you'd like to do. And I'll post links to all this stuff. This is all very usable in the browser right now. You can use these for nice little enhancements anywhere that you'd like to in your work, button hovers and things like this. So it also, basically everything you're doing is going to be built out of rotation, scaling, and transforming from one place to another, removing the left and top positions. And you also can do a little trick with skewing. I'll show you that a little bit later in the SVG animation. There's a character's mouth that we get some animation that way. So all of the different properties within the longhand way of writing the CSS transitions, we have, and this is with and without prefixes. You need to do vendor prefixes for a lot of these things. Is anyone here that knows Sass or less? So mix-ins, so you say, this is my property, and it automatically decorates it with all the vendor prefixes. That's really, really handy for dealing with this stuff. We have the actual transition shorthand, or you can specify each component of it, like how long you wait before you begin the transition, how long it takes. Interpolation functions such as easing or moving suddenly or accelerating or decelerating. There are several built-in functions to give an animation a feel. And then which properties you're actually going to be animating. So that may be opacity or the position or things like that. Within the keyframes, it's a similar set of things. where you define the actual name of it. It's almost like a font face declaration, how you define your keyframe sets, and then you apply those with other properties to your actual CSS declarations. And it will play the browser will play them back automatically for you. And so that's pretty much 2D. 3D is a little more fun. You can, again, these are just DOM elements being transformed with certain criteria, with certain hierarchical relationships, and you can start to get things that feel like they are solid surfaces. So in this case, you're translating along the z-axis. Just as a really quick thing, and next month we have a great 3D guy, David Lyons, who's going to explain a lot of 3D theory, Three.js. But basically, you can rotate things on the y-axis, which is a vertical sort of an elevator shaft. If you're to move the building around the elevator shaft, it'd be just sort of turning and looking different directions. You can rotate it along the x-axis, and that would be as if you took the whole building and sort of turned it on its side, like this. Or you can rotate it on its z-axis, and that's the building sort of tumbling over. Well, I'm not making any motion sick there. So those same ideas can be directly put onto little divs that just happen to have little nice colorful images in them. And so that's all we're doing here, is we've moved one forward toward the camera, one back, each of those 150 pixels in each direction. And then we're just rotating the container itself using an animated transition. And the browser is doing the rest. This is very broadly supported. So there are a couple of toggles for exactly how it might do this. This is without perspective. And here's toggling to where it actually does calculate something called a view matrix that kind of pulls it out and distorts it toward a vanishing point, if anyone remembers like drawing class or drafting or something like that. But the browser can also do it without. And these are just differences in the declaration of the CSS properties. So the viewer point, the point of view, the camera, a bunch of different ways of describing it. Perspective basically just says that we're transforming all those things in a way that makes it vanish with distance like things do in real life. So there's actually, you can hook together quite a few things and using perspective do some very interesting stuff. Like here, we actually have declared 6 different divs that all have the same parent, and we've just shifted them forward and to the side and rotated them just so they have these relative orientations to the center, and then it has a parent DOM element that we're applying an animation where we're just rotating it on X, Y, and Z. So that's the difference between using the perspective rotate and the non-perspective. So basically, this has been done enough to where you have a certain way to structure your DOM to get pretty good predictable results. There's a containing div or something, or sometimes I've seen this on the body element that's sort of considered your scene that you set the perspective on, and everything is a child element of that. So then you actually have the parent, I guess you could call it, they're calling it the object here, which is the DOM element that contains all of the other things that you're actually transforming. And there we go. So this colored image is nested inside of the thing that we're actually manipulating it with, which is nested inside a scene that gives us our perspective. And perspective is important. If this browser was a different size or something like that, this would all go kind of wonky without trying to control it.
Does this have Firefox does its stuff with that 3D rendering page?
Oh, the DOM inspector where they actually use WebGL to...
Yeah.
Yes, I think they use WebGL and they use that to visualize it. Have you ever seen the horrible abuse of that where somebody built a log cabin structuring the DOM of their web page to actually... Yeah.
But I did use that to find what somebody thought was a virus one time.
Oh.
Somebody had planted a known Nemon, I think it was, virus. It had the same signature, but we couldn't see it anywhere. But when I viewed it in 3D,
you could actually
I saw this little thing up in the top left, way out, about 1,000 pixels out.
Oh, wow.
and I saw
Yeah.
it, so I zoomed in on that, saw what it was, and I realized, oh, crap,
So-
that's not good.
Was it user uploaded content or a script injected it, or what did
It was
happen?
actually a script that was used as part of, somebody used a component on a site, and it just so happened that then put in the signature on that, happened to match a known virus.
Oh, well, that's good.
Yeah. No, well, it was a known, it's not a virus, it was more like a Trojan or whatever.
I'm glad there's a happy ending.
Yeah, it was happy.
So all we've done here is added subsequent child divs that have this texture and transform them differently. And they're all just inheriting. They're along for the ride. All of their calculations are derived from whatever's done on the parent. So, does anyone here have like 3D animation, character rigging, anything like that? So that's a very typical way. If you have a character walking, then their body is the parent of their arm, which is the parent of their hand. And so if you move the body, all that stuff comes with it. It's the same idea of a hierarchy. Also a lot of DOM styling and calculating. It's a very analogous idea. So like we were saying, we just have a sort of a parent access object, which is doing all of the actual calculation. We're just mapping it flat in the containing scene. And then we have our 6 different faces, which are shifted along the correct axes and rotated just so. So what's really fun is you can have, say, a hover state that has all of your transformations. So they maybe each of these are 150 pixels from the beginning in a normal state, and we're just rotating the parent. We can have a hover state where, say, they're 300 pixels, all of them, and then just tell it to animate that transformation. So you can, this would be a fun little thing, maybe a shopping site. It's the Amazon Gold Box, move your mouse to see what's inside or something like this. So there's a lot of sort of out there enhanced stuff you can do. Any questions on CSS 3D and 2D?
So far what you showed is the left pixel, right? It's not going to work in the IE, right?
Oh, it definitely does work in IE.
Even the same video, the left pixel high contrast, my thought is
You need to correct vendor prefixes, but Microsoft, as of IE10, made a huge deal of their HTML5 support. So it's a good browser again. You may need some extra prefixes to use it, but there are tools that can help automate all of those prefixes.
even with webcam.
Yeah.
Can you show us how you're automating it with those to support those vendor prefixes?
Sure. I'm to show you SAS vendor prefix.
So I've been using last night. You've been telling me that I need one of the SAS. What's your take on that?
I personally have only used SAS,
Okay.
so I like a lot of the power of the language. There's some ways of doing less that burden the client with some pre-processing, and I'd rather do it in advance before you deliver the CSS to the client. SAS has some very powerful stuff around using variables with your breakpoints. So you can say that my breakpoint is 400 pixels when I start considering this to be a tablet instead of a phone. And so you can actually formulaically set all of your media queries and nest them wherever it's convenient rather than having to put them in an awkward outer place. And you can say that from min width 401 pixels, you say you have your SAS variable saying breakpoint plus 1 pixels, and so it just really helps with a lot of stuff. Style guides, and you can say this color is the same. It's brand blue. It'll be everywhere. Helps with theming and stuff. So SMAC's scalable modular architecture for CSS with SAS is really a good approach.
So is that another project? Modular?
It's more of just a way of organizing all of your CSS systems as they start to get more complicated.
Okay.
So I'll post at the Front Porch conference. There was a really good presentation, smacking your SAS up. Okay, so here's a Stack Overflow answer that just does it perfectly. Let's see here. Well, maybe not. So here on this border box, which you used to always have to have the prefixes, wouldn't it be nice to be able to pass in what you actually want and have it generate everything else out? There we go. Okay. pretty good example of how you would do it. So transition is a mix-in that you define within the Sass language. Okay, and this all compiles out to regular CSS, and you would just pass in just the val, and then it would automate the generation of all of these prefix things when it actually spit out your CSS. So you would write this once, and then anywhere in your CSS you wanted to say transition, it would automate all of this generation. So that's sort of the idea.
Okay.
Have you heard of prefixer?
Is it?
It's pre-processed or agnostic. It's something you do after you compile.
Okay.
So that when you're writing your Sass or Less or CSS, you just write the base property, and you use this like prefixer.js to basically go into your document and add all the prefixes to the right properties. You can specify which versions of which browsers you're wanting to support, and it knows to not add prefixes to certain properties that don't need it anymore. So.
Does this look like the project?
I believe it's just prefixer right there. Yeah.
So that's an interesting approach. And
Right.
put it
And
in
if you're using like a grunt or a
yeah,
gulp,
put
it's
it in
got
grunt builds.
yeah, they've got plugins for it there.
So here's a nice demo. So
Right. So the benefit of that is you don't have to worry about in your mix-ins making sure you have the right
yeah,
prefixes. As browsers add support, as long as you're saying like maybe just support the last 2 versions, it
Yeah.
knows to stop adding prefixes at a certain
and
version.
if your analytics people tell you now you're supporting this browser, now
You
you're
just
not.
add, now to support IE 10 or 11 or 8 or whatever.
What's your rendering engine here? What is this you're using?
So it's built into the browser. It's using some hardware acceleration
So
on the
this
GPU.
is not a presentation, this is a browser.
Oh, yeah. So that's very important to mention. We're actually in Chrome, regular old Chrome. Unfortunately, this presentation is geared toward WebKit. Since it's a Google evangelist, I don't expect it to work in IE, but it could be translated fairly easily. So this is just also right in the browser. We can, in fact, for Brave, we can actually use the inspector and see all of this stuff. And so he's actually got the object, it's apparent, it's exactly the way he's described it. And then each face is an image. So it's just all right there. Inspector. Okay, so the next major approach is scalable vector graphics, which are cool for a number of reasons. Really mature. The spec for these has been around since 2001 or so. It's now they do a lot. They actually exist in the DOM as its own little hierarchy of elements and sub-elements, and so you can actually do interaction and on the different components and things like that. The SVG itself is built up of different primitives. So like a line element, and it takes several attributes that describe the characteristics of lines, such as the starting point in X and Y and the ending point, and a rectangle with a starting point at X and Y, and then its width and height, and a circle with its center on X and Y and its radius. And so you can just very easily use these primitives, and it will do all this magic drawing for you. It's almost like if this other stuff is like 3ds Max for you in the browser or something like that, this is more like Illustrator in the browser for you. So you can also, within your SVG, you can have images that do external references and things like that. So here's sort of the basic idea is that you have an SVG element, and within it you have your rectangle element, and it takes all of its attributes, and the browser just draws it for you. So you can do some very nice pin tool based things. You can, if anyone's familiar with Illustrator or a good vector program like that, you can define paths just like you use the pin tool in an Adobe product. And you're describing a starting point and control points and final points just as a sequence of X, Y values here. probably wouldn't want to draw anything too elaborate this way. It quickly become very overwhelming. But you have that level of power. You can programmatically, if you had JavaScript, you could be calculating and changing the contents of this attribute in JavaScript to manipulate vector art in real time. If you want to take that approach, you have some other approaches to that. So it also has transformations using a lot of the same engines in the browser to do that. It's actually just, rather than the CSS property, it's baked in as an attribute that you can put on all these different primitives. It's a very similar syntax, getting completely away from browser prefixes in these cases.
Why would you do that versus, because you can do those transforms directly in CSS, so.
If you had a very, okay, one of the best uses I've heard is someone who makes their mock-ups in Illustrator, and there's an Illustrator saved to SVG. And so if you name a little layer of artwork or something in Illustrator, that will export with a certain ID to the SVG. And then you just drop that SVG into your HTML page and program interactivity against it. And so in the case of making a little prototype or wireframe or a mock-up or something like that, you can program behavior saying, okay, I've now clicked this thing, animate the mobile layer in, and it comes in and does this thing.
I see.
I mean, there are other uses too, it's just how it's really.
And these aren't really good examples. It'd be like rotating just the phone in there, or rotating just that circle. Like, okay, you're about to get to that.
So actually, yeah.
All right.
So let's take our little robot SVG there. He's made up of a few different little pieces, and we can actually animate all of his little pieces. And of course, this would be a lot harder to do in CSS. You could, I mean, you could have his little mouth, and you could do a skew kind of thing on it. On the board could be a div, and you could skew it. But this is all completely within an SVG hierarchy here. So by applying the animations directly to the SVG components, in this case, we're just taking his little wild pupil dilation, just the varying radius here, just this element of that. And we're saying that we have an animation on it that lasts 3 seconds. We're changing the radius attribute on this parent tag here, and we're changing it from values to have following values, 80, 150, and 80. It's very much like defining the keyframes in CSS, and just have it repeat that indefinitely. So it's a little different than repeat infinite in CSS, but a lot of the ideas are the same. So kind of taking it further, here, this isn't a skew that he's doing so much as he's actually taking all of those points in the artwork, right? And he's providing 2 different sets of values for them, and just having it go over 2 seconds between them. For those who work in Flash, this is very similar to a lot of the interpolation and stuff that can be done there. I think it's a lot cooler because it doesn't have to build out of a proprietary tool, and Flash would actually hard-code all of those frames as little snapshots of vector artwork that were baked into the final SWF file. This is totally dynamic in the browser, and can just, actually just for fun, let's see if we can identify something in the path that we would want to try changing. So let's say instead of -4 being the starting X of the corner of its mouth in the beginning animation, we want -3. And maybe that difference isn't big enough to see. Oh, here we go. Okay, so we can say I actually have to do something. So one of those frames of animation is now way up here. The coordinate space is way up here. So I mean, no saving out of Flash or anything. It's all just real time right in there. So here's I think this is. Let's see here. Sorry, this is just a grouping. So you have it's just like Illustrator. You have the group element. And then you can deal with several things in one go. So while these different circles and things on the, I guess you call it skateboard or whatever, They're all subcomponents, a couple of circles and then this Bezier shape on the outside. You group them together, you can just animate all of that together. So it gets pretty powerful pretty quickly. So you can also animate things along paths. This is a very Flash-like idea where you are defining the different positions that something will be painted along across the animation. And then you can use different interpolation or easing functions to do things as well. So I don't know if you can see, but when we toggle from the spline mode to the ease in, ease out style, when it gets to the edges of the animation, you can see it's either it slows down and accelerates or is jerky. So here is the jerkiest it is versus using this. Anyway, you have a lot of options. If we're just bouncing a little logo in with a progressive enhancement, it's very straightforward to do those things. You can also put things within the SVG that are interactive. So this is obviously not a very unobtrusive way of doing JavaScript, but you can just say that we're going to, it has master controls for the SVG itself that you'd either pause or resume or rewind. So with some tools, and probably Adobe will make them too, you have a lot of very flexible animation stuff you can do. So that's just kind of a summary of some of the syntax. Handwriting SVGs is not really a big thing, maybe hand tuning them to do some interactivity and might be a good approach. So we're through the first two. And this is a good difference. When you're doing CSS animations or SVG, you're basically setting some properties or setting some attributes on elements, and you're letting the browser do everything from that point. It interprets it and runs it how you like.
What does SMIL stand for?
I'm so sorry, I actually have to look that up. Synchronized multimedia language integration language. So it's part of all the.
And you say this is supported, the animation piece is supported across all browsers? Without any differences?
I know that Smile was used a lot in real audio.
Oh.
Yeah, they were real performance with Smile. I haven't seen that in probably about 8 years.
Well, that's probably a very old flavor of what to do with it, but
Yeah.
it's interesting. So our support is really nice for this across the board. So long as you're not targeting iOS before 7. Or 7.1, that's surprising. But let's see. The Android browser since 4, so most of the market, relative usage. I mean, this is pretty good support. Chrome for Android's really taken over. It's actually overshot the manufacturer browsers. And, it's right there. So I guess I'd also look at mobile. You guys probably thinking desktop more. So Firefox and Chrome, and actually I'm surprised that the SVG stuff is not in IE at this time. So,
It's the animation piece. Yeah, SMIL.
Yeah.
Just that.
SMIL part.
yeah.
But I was surprised that you got SVG and HTML, but it's SVG plus SVG.
But you can put them directly into the DOM, which is something I learned a little
Like
bit
it
about
existed
recently.
even before HTML.
Yeah.
That was the problem.
You said you wouldn't write it right now, but what other tools that you use
I would have to post some links. I'm sure Adobe is part of their creative file. They have some experimental things. They probably have something. They're probably some good source links.
As far as just SVGs go, Illustrator.
Yeah.
But I just meant to animate it. Maybe you can build an Illustrator or
You could just experiment with hand coding different properties a little bit. I mean, I wouldn't do lip syncing on the character talking to morph the team out for typing in control points, but that would be a good way to get started. And it's probably the kind of thing you want to do more as a progressive enhancement anyway. So it's like, sure that logo's up there, but in the right browsers, it's going to do something special.
I guess what on one of those techniques it showed you could actually like create multiples
So any SVG component, you can create an animation element under it and manipulate the properties above it, all the attributes on it. Or you can group them and manipulate all those things together. Or you can have animations doing things within some elements, and then broader animations doing things on bigger elements.
I was just wondering, with the animations, would it slow down on a mobile device, or is it just the same as a desktop device?
Well, it depends on what you're asking of. Mobile device performance in general, just say browser JavaScript, has just been just about exponential over the course of time. So we don't actually want to run it. I was even noticing back iOS 4, iPhone 3GS versus iPhone 4 and 4S with iOS. As soon as they hit iOS 4.3, the JavaScript execution sped up a lot, the graphics performance. So we're getting there. I mean, depending on what you're targeting, you can do a lot. There are things if it brings your computer to a crawl, that's probably going to bring your phone to a crawl. But we're getting to the point where a lot of the things that work reasonably well on your desktop browser, you could do some version of them on a mobile browser.
Okay.
For sure.
Have you looked into this? Is it the Qbox attribute
So I have not done much with CSS3. I've done a little bit with Canvas 2D, which is our next thing.
Something out there called Inkscape. That's pretty interesting.
Okay, yeah, I think I've heard that one. Is that an open source?
Yeah, sure.
Yeah.
Yeah, so this is kind of an open source version of Illustrator, if I'm not mistaken. So
Screenshots look pretty cool.
I mean, it looks like it has great gradient features and things like that. I wouldn't expect those to work in SVG, so that's a bad example, but it's a good Illustrator alternative.
It's native storage format as SVG.
There you go. It wouldn't surprise me if this had some animation features, where you could create keyframes within it, those quads, but not the same.
I'm curious to know if those images are saved in .svg.
Oh, their thumbnails in the
Yeah.
gallery? Obviously, let's check that out. I mean, it would make sense they'd save off of. No, they are.
They
So,
are. Yeah.
that's true. So, of course, that means they're fully scalable as well. So CSS3 and SVG are basically leaving some instructions for the browser to deal with as it sees fit. You're sort of setting and forgetting. More of a programming thing where you're maintaining a loop in real time and you're running code again and again that checks on the state of things and moves things around and redraws them. That's a better description for Canvas and JavaScript. And 3.js is much the same as well. So Canvas is an element that you can drop into the page, and I'll play that again. But it's an element here that is just sitting in the DOM immediately under the heading, and it's sizing from this is that whole blue region. And so that's just sort of an area that we can draw on with JavaScript. We can draw a frame and then erase the frame and draw a new frame. And with a library such as Box2D, where we can simulate gravity and collision and some physics and fun stuff like that. You can actually begin to simulate. So on this click event, it's beginning to run through the draw loop and calculate where the boxes would fall. So it's a JavaScript library. There are actually several ports, Flash, different things. It's been used in game development for a long time. And you can use this in a web page. Here's actually the project site here. And so you can just program interactivity where I'm dragging that up and bouncing off the walls and don't have to code any don't have to be familiar enough with physics to write these things out.
If you wanted to do a full actual application with this, almost like a full screen application, what kind of overhead are we talking about?
Well, it depends on what you're attempting to do. So, for example, one trick here, you see that this is a canvas element, and it's only this large. So you're not asking the browser to redraw. So it's 400 pixels by 600 pixels, 600 wide by 400. And so redrawing that whole thing is less overhead than if this was the entire span of a monitor. If it was redrawing 1,000 things every frame, trying to keep up to 60 frames a second, that's very different than this.
I'm thinking more of a dynamic reconstructing, let's say, tables and things like that. We're using SVG as opposed to straight up HTML elements or table, whatever you want to use there.
Actually, there is the canvas is the new spec, right? So SVG has been existing, so there is an elaborate article that says the performance improvements we use canvas directly, right? So even for the there is performance.
I think SVG was the slowest at this point, right?
So SVG is a Microsoft spec, right? So the canvas is coming out from the HTML.
You can do all kinds of fun little stuff in Canvas. I don't know if anyone here was at the talk on this. But this is a 2D canvas, just in that area there. It uses an image, reads in the pixels, and then creates a simulation where it's animating at every frame and doing various things with these pixels as part of a particle system. So anyway, Canvas is a lot of fun. You set it up, you just declare a canvas element. The attributes are actually very important here. It's actually how it will be rendered and allocated in memory. The CSS styling is just more decorative. This is actually how it's allocated in memory. Then in JavaScript, you programmatically go grab your element out of the DOM, create something called a context, which is just sort of a way to access the API for dealing with it. And you can do things with the context, such as clear it to black in between frames, goes to the side. You can also change basically out of your CSS color properties, anything RGBA or RGB or just some of the properties that are available. You set up the context and you draw with coordinates in different modes, closed path mode or open path mode. Eric Sal was here, he gave he live coded Pac-Man and run across the screen, and it's just an arc at various radiuses. Did that. So it's basically here you get a lot of performance, but you're very specifically moving exactly where you want to go from moment to moment to draw a pixel or begin to draw a path and things like that. So it can be slow to create things. One of the nice things you can do is you can drop a whole image in on canvas at once with one little draw image, and that's a very fast operation versus you can build the whole thing and draw it in SVG. Interesting. You can also so you could drop in a PNG or a JPEG and draw. I didn't know that the context of draw image would draw an SVG screen. I just learned something else. I'm sorry. But it can draw in and keep all of the resolution. Apparently in Chrome you can't animate it or anything. It's just a snapshot of the SVG. So here, just getting into sort of the box 2D stuff and interacting with clicks to change some of the properties that we're drawing down that SVG every frame. So when the mouse gets close to it, it displaces it with the box 2D. So So this is just sort of the nice, fun, fast stuff you can do, and because it's doing SVG, then it's scaled very large.
So Canvas was the whole slide
Yeah.
and transparency, and then it had 3 SVG objects on it.
It actually is all canvas, and what the JavaScript was doing is drawing those SVGs over and over again with different transformations. And it's much more manual than just saying CSS3 animate this for me, or SVG animate this for me. So that we can. So if we actually probably a little more difficult to get into JavaScript doing this, but if we were to do something like print a console log every time it drew one, it's like
I see.
JavaScript's doing the work. So this is a more hands-on way. When you change your canvas context because you want to resize and draw something, I guess on CSS you can sort of declare things in any order, and they're going to behave pretty predictably and say, I want to scale it, I want to rotate it, I want to shift it. When you're dealing with canvas, you need to be a little more strategic. So the very first thing, you create the center axis of where you're dealing with your graphic. Then you do your scale transformation, then you do your rotation, and then finally offset. So if you're to do this in a different order, you get a different result. So that's something you have to worry about with canvas. Within your JavaScript, you're actually line by line deciding to draw the world, and you usually break your draw loop and your run loop apart from each other. So it's you're deciding at every little frame what's happening. Questions on canvas? So I have the source code to the laser thing. On WebGL, you're also setting up a canvas, but it's a 3D canvas. You're going through and you're using OpenGL ES 2.0. I know on mobile browsers that's what we're finally supporting. The 2.0 standard is pretty cool. You set up, essentially you're defining geometry, just XYZ coordinates in space and arrays. So it's numbers and arrays describing points that connect together in meshes, or to form spaceships, or whatever you're doing inside 3D, form little characters or whatever it may be. And you take those and programmatically use OpenGL to register them with the graphics card. And then you do things to transform them and correct them for perspective and move them around, and then tell the graphics card to draw them to the screen. And when you have them drawn to the screen, you have 2 types of little mini programs written in the C-like language called shaders. And as they're drawn to the screen, the graphics card will run the shaders on the graphics hardware. And for example, if your thing is a flag, which is a mesh of geometry, and you want wind going through it, you could have a shader that would displace all the different pieces. And then you have a shader that decides what color it is. And so if we're right here, we're on a star texture mapped onto it, but over here we're on a stripe, or whatever it may be in the example. Three.js makes a lot of that complexity disappear. And next month is a real in-depth on Three.js. But okay, let's see if it works correctly. So here we have an entire 3D canvas that we animated away the slide, and this is still in the browser, but we're using the mouse to decide how to manipulate the camera view projection. So all of these, yes, okay, here we go. So we have some interactivity. Here are those arrays of integers that form geometry I was telling you about as we get really, really close. Oh. Okay, that's the history of Android, of course. So these are actually made up of, like the torus is just made up of a bunch of individual points connected into polygons. And some of them have the attribute of being colored, donut colored, and some are frosting colored, and so on. And so the graphics card is drawing all these things, and we are with JavaScript telling it every frame to slowly rotate them and things like this. And so it's a lot of code. Three.js makes it easier, and you may kind of leave it a bit abstract like that. Any question on that part? Oh, actually, we'll go into it. 3.js is a series of, it gives you a series of abstractions. So a lot of code you write by hand. You can set a renderer that will do the work of drawing and communicating with the graphics card. It has a couple of simple things like how large a canvas you're wanting to do. And then you attach it and create a camera that, as we were moving around, Three.js was managing the coordinates of our camera. That you kind of remember the original Star Wars, they had the Death Star sequence and they had the motion controlled camera going along that big model or whatever. Anyone kind of know what I'm talking about? So this is the same idea of camera. You are computer controlling the coordinates of a camera flying next to a model and then seeing what it looks like from that camera's point of view. So 3.js lets you set that up and animate it and worry about a lot of other things with that. You also have lighting sources that you declare. And it is under the hood doing all of the things to set up the shaders with the actual WebGL to get your lighting effects and texture mapping. And so here's a much simpler example. This is a canvas, 3D canvas, and this is a little different than we were seeing just with regular CSS animations. Namely, there is shading. You know, back here, these spaces are darker until they start coming in toward the light. Up here, it's brighter. This is not something that you can get in CSS 3D animations. Certainly not where the different corners of it are different values of light and dark. So this is the kind of thing that WebGL is better at. You're programmatically running a JavaScript function to do all of your drawing, moving, recalculating, drawing. One nice thing 3.js does is if you have 3D Studio Max or a video game asset or various 3D models of the Android versions, Cupcake and Donut and all this, you can use 3.js to load those in and it will automatically create those arrays of geometry for you, which, yeah.
So what's the difference between it? Like, I remember a lot of people use OBJ files for the same thing.
Yeah.
I used DAE. What's the difference between the OBJ?
So they're different 3D format things, but there are OBJ to actually JSON is a popular way to stream in your geometry, and so there's an OBJ to JSON things like this. So 3.js supports a few things, and I think it has extensibility where you can include extra libraries and deal with other formats.
What's the recommended way to store your 3D model? I guess DAE.
Most of the tools out there, the 3D stuff, like Unity and stuff like that, or except DAE, you use stuff like Blender, and you can export it to DAE.
Well, there are a lot of different formats that are supported. It's a lot of it all started in a proprietary vendor-specific way because Alias Wavefront had one set of packages and Autodesk had another, and so on. They're all just sort of universally supported, or you could get a workflow to where you can convert it to what you need for this. I guess it has to do with your workflow. So I mean, if you're a game shop making web games and you have a 3D studio expert and that's who's on staff, then that's your workflow is to go from that into, and probably have a translator. So they may live in 3 formats, in your workflow. I don't know best for better. So just to recap, 3.js gives you a renderer, which is responsible for drawing the scene, camera, which is responsible for essentially warping reality to look like it's coming from a camera, light, which provides information to the shaders for which areas are bright and dark in the scene, and in a way to stream your different geometry. So then the last major thing, and there was something in the spec that has some beautiful demos, and I'm just going to show you some of the demos, and then we can basically wait and see if it's coming back. Let's see. Of course, I've hidden it somewhere. Let's see. Okay, here we go. So basically, imagine if you could do some of those 3D effects like you can in WebGL, but you apply it like a CSS property. And so sort of the vision of it was this kind of, so you take, that's a div, and we've subdivided it into geometry and rippled it into things, and all that is a couple of CSS declarations where we point it to a shader file. So the map unfolding and things like this, real-time 3D without having to do WebGL. So unfortunately, it's been nixed from Chrome Canary for the moment. So it kind of rose in 2013. But I mean, you're just going through a slideshow, and it's very, very little work for you. You download a shader from somewhere and stick it in your site, and you can do effects like this. So that is the vision. I could not get a build of anything that would run that right now. I suppose I can go into source control and try and build Canary potentially, or some good ways to do that. But
do you think the other companies are on board with that, or is that pretty much just a Google?
Well, Adobe really got behind it. So they created a huge demo site and everything, and they created what they called a filter lab. They've got it all open sourced here. Fortunately, none of the demos work correctly, but I think they were really looking to make this the HTML5 magic coming out. So the conference in Germany that this is based on was 2013, and unfortunately, it's nowhere in the Chrome flags anymore. Let's see. I actually pulled out the bad news. Yeah. So it's on the WebKit lists proposing moving it, removing the feature entirely from the nightly build. And there's good information about it out there, and it may be back. So it's getting close to the end of the presentation to talk a little bit about how they work. So does anyone remember CSS filters or use them? Brandon Satrin came up from Austin and gave a leading edge HTML5 talk in 2013. And so this is one of the things you can do. You can use a WebKit filter, and there are several, drop shadow, grayscale, blur. Drop shadow is a bad example because we can get this otherwise. But so you could actually take an image and blur it right in the browser using a web filter. And for example, on a hover state, remove the blur. So you have a little, let's say you have a gallery, you have 5 images, you're using a blur filter on them, and so you can have them kind of come into focus and do neat stuff like that. Filters that's the idea behind them. The idea with the shader filters is that you would install a filter that actually did all this nice 3D warping. Not too soon, unfortunately. Basically, you're dropping in, this is called a vector shader. It's a geometry distorter shader, very C language-like low-level thing that runs on the GPU. And to be able to declare that, compared to setting up WebGL or something, this is very, very clean, nice syntax. So say we just want to do something that would animate a flag blowing in the wind, and drop it in there. And so to take the idea behind it is take the DOM element and divide it into geometry automatically. No 3D context canvas, no worrying about any of that, and just do nice effects on it. And you can pass in things to your shaders. So in this case, curl position and direction and things like that might be what this particular shader uses. If you were to look at that, it would be a text file that looked like C level, some specific stuff. So I kind of envision this as being something that designers would swap pretty much finished shaders, or there'd be like collections of them because they are very involved and intense to write. Hopefully it'll come back. So we just have a regular old div, and just by applying that filter, it would consider it subdivided and run the shader program. And it's not going to do this. Not doing apparently it would be fluttering right now. This is all really cool stuff, but since it's not that. Shaders are very, very math intensive. So basically, like the founders of Pixar were, like Ed Catmull, and into texture mapping is I believe it was his doctoral thesis. And so a lot of the stuff to do this is very, very math intense, very computer science intense. And to be able to just drop it in as a declarative CSS property is really fun. But just use it for things like page curls that are actually as if the thing is coming up, hitting light, and folding in on itself in reaction to user input. So, yeah. But that's kind of all the approaches for animating in the browser as of now, or in case of CSS shaders, perhaps never, or perhaps next year. Totally open for questions. I'll put all the links for this stuff up on the site. And I have an HTML5 animation book to give away as well. If you have any questions.
Did you do that Contra animation?
I did.
Oh, wow.
Do you want to see the source code on that? It's like just a couple pages. So the basic idea behind that is I'm creating an array of particles that exist of the coordinates and colors of. So basically, I take an image. Let's see, animations is the which is the articles. Okay. Probably that's a lousy font size. Okay. So just some simple JavaScript. When the window loads, we go get the canvas element and hold on to it and get the context. And then I have a little method called setUpParticleArray where I pass it in an image. And I wish I could jump to definition, but we'll be doing some scrolling here. SetUpParticleArray. So load particles from URL. Okay. Yeah, create an image element and essentially set the source of the image to what we're passed in. It loads in. I use the load event on the image element to fire a callback when it's done. I then copy that image to a canvas that's the same size as the image, and I began to walk over in a couple of nested for loops all of the different pieces of that canvas and read the colors one by one. As I do that, I'm actually building up an array of objects that just have the RGB values and some other information that I end up using instead of array. Let's see. Then I map that into the final. Each particle has its color value, which would be what I change the context of canvas to draw it, as it comes back, so I get the same color as the original image, and then its coordinates. So basically, it's an array with a bunch of these. It's about, I'm thinking 7,000 or so, and it draws pretty well in the browser. Then I go through that and I call various functions. I guess the main thing is I have an idea of a float from 0 to 1 of at what phase in an animation it is in any given moment. So if it's early in the animation, I would do something differently than when it's at the end. And then actually use that in this other file to using different techniques. So here's the time state calculator, different animations that we can choose from. I called them the showing animation, and it had a separate update function versus hiding versus scatter. So just to kind of see here. So this is what I call the showing animation, and so it's essentially going along, and based on how far you are into it, it's applying itself to different sets of the particles based on their how far to their horizontal position. So over time, it applies itself to more of the horizontal positions, and they move to a position closer to their natural one than one that's very squished on the line. And I just happen to be having an axe flat line, so it does that. The ambient one I actually call from the other animations, so you kind of see once it gets to a certain point, it begins doing that holding pattern. You can see it ripple across there. That's just calling that thing. This is just no longer calling the ambient at the threshold, depending on the X. And at that X, I'm just beginning to kind of do a drift downward. It looks very gravity-like or collision-like, but it's just it's kind of simple. It just looks like it's doing that stuff. So here's the scatter, and maybe not the best JavaScript. This is a lot of it. Yeah. Okay. So it's just basically based on time and position, deciding how to draw. It's sort of a short answer.
So on a different subject, I mean, you do work for Match.com. How is HTML5 affecting you on a day-to-day basis from the work you do for them? I mean, in real life, or this is kind of, I'm just asking, what's your perspective? How does it affect you?
Well, this has all been a couple of TechCrunch articles. Match got into a money fight with Apple and got thrown out of the iOS store since 2012.
Wow.
So it affected things in a very real way, because we quickly built an HTML5 app to kind of make up the void of not having it in the iOS store. And so things like being able to store information on the device in between sessions, or we didn't do a lot with animation necessarily, but being able to do good APIs for, there's some JavaScript APIs for uploading files, so you know the progress as you go along. And so being able to say, okay, I've taken a photo of the camera on the phone, I can use this API to do a progress bar, and we're uploading it on 3G. You know, there are just a lot of different things that were very useful. Some of the offline APIs. And then doing a lot of touch interaction and CSS3 animation. We have a feature where basically Match, you're looking at people, profiles of people, okay? And so before you look at one, we show you a list and have you choose one that you want to see. So it's sort of like an overview and then a detail. So we have one feature where when you're on the detail, you can look at the next one or the prior one just with a little touch gesture. And so that uses CSS3 animation to shift over as you go along.
So like, this is interesting, but like, I'm on Android. Is it the same code base? So or is it, no, I have an app for the iOS and an app for.
Except for all of the different bugs. So I just love pretty much any can I use graph. I mean, what we were looking at earlier. So you just get such a mix of things. So we really were prior to 4.0 when Google put Chrome on Android. We were actually dealing with every manufacturer separate. They would fork the browser, and as far as I'm concerned, make it much worse and break things. And then we'd have to write code that would run on everything. So we have feature detection and all kinds of stuff everywhere that we were dealing with.
So what's your threshold on the browser version? Like, what version are you aiming for right now?
Well, that's mostly our statistics people tell us what people are using,
right.
And then so we can make decisions about how we support or target features. We have one feature where you drag a photo to one side or another if you like it or dislike it, and so things like that. And, so we sort of have a window of support rolling forward, and occasionally we get very happy when somebody loses market share, say maybe BlackBerry or somebody that we want to support. Does that answer your question?
Yeah, definitely.
So it turns out not having an iOS app has actually maybe been a bit of a blessing in disguise.
It was for the short term. They, of course, all things at Match.com have happy endings ever after. So we're back with Apple now. Let's see if I can. And that came out last year. So it's been back in the App Store since April.
So why did y'all leave initially?
So Apple, in an effort to monopolize the world, decided that everybody who had an app that did a transaction in the app owed them 30%. So I think that was the original reason, not 100%. I'm not important enough to know those things, but I would take it. It's a beautiful app now. So now this lives alongside the HTML5 app. And so somebody's committed enough to download it versus if they, I don't know, click on an email and it goes to the browser instead of the app. It all just kind of works. That was pretty much all I had. Thank you for coming, and I'll have a lot of stuff up on this book is going to have good support because it came out a couple years ago. Good tome on animation, talking about everything from parallax scrolling with JavaScript. Should I do a trivia or? Oh, you raise your hand.
Yes.
It's all yours. We're going to get pointed after. Thank you all for coming, and next month is going to be a really interesting talk on Three.js. So.
When is that?
It's more WebGL.
Okay. Next week or next month?
Oh, sorry. Yeah, that's it.
It's on the Meetup already?
It is. It's we announced it. It's this one right here, November 19th. We tried to time it far enough in advance of Thanksgiving.
Yeah, I mean, it's not easy. You know, this one's limited, but they're including it in a lot of these this other one.
I'll work on it. But thank you so much.
So we could get things going. So I'm just gonna do a little 15-minute kind of introduction to Go. I've been messing with it for a few months now, and I think some of you might be interested in it. So for HTML5 apps, why would we care about Go? Mainly for server-side stuff. And that could be anything from just a regular like web server functionality to really complex web services. Go was developed at Google. These three employees that were pretty old had done some pretty major projects. We're getting frustrated with the tools at Google to do large, high-performance systems, which they're mainly doing them all in C++. So they came up with some ideas, and then eventually the ball got rolling. They got some more people involved with it, and started picking up a lot of steam. So this started about 4 or 5 years ago, and became a real product probably, I think, like 2 years ago. It is open source though. Google's kind of running the show, but a lot of people are involved with it. It's statically typed, compiles to an executable, and no runtime is required, which I'll talk more about that in a minute. And it is gaining popularity quite a bit. How many people have even heard of Go? Most have heard of it. How many people have played with Go? Nobody, not really. Okay. Statically typed, does that mean anything to most of you? If you're just in scripting languages, that's kind of like, whatever. It's kind of a big deal. Let's go around the room a minute. Just out of curiosity, how many people are just using like a web server to do all their web stuff, like Apache or Nginx? That's the only thing that you use. So how about Node.js? Do that. Python frameworks? Nobody's doing that. Ruby? No Ruby on Rails? I've never used that. Doesn't work good. How about .NET? Java? What Java guy? Any other ones that people are using to do the server side? PHP. Oh, PHP, right. This is not a commercial, but if you want to play with Go and you want to host it on the internet, not just on your PC, you need something like a DigitalOcean that will allow you to install what you want on there and also have long-running processes. I use it. It's $5 a month, no contract, and it seems to work well. So anyway, you do have to. I kind of like give you documentation, and here's the box, here's the documentation, go do what you want. So it's a little more to learn than maybe some other hosting situations. Okay, some of the key benefits of Go. First of all, it's really easy to set it up. You go to golang.org, download some stuff, install it. It's really simple. And deployment is probably one of the biggest things, biggest advantages of Go. What it does is you take all the source code of your projects, your third-party libraries, the Go standard library, all of it, and when you compile it, it creates a single executable file. You can take that one file, go stick it on any server that you want, and if it's compiled for that environment, you start it up and you've got the whole thing. You don't need anything else. No libraries, no runtimes. You don't even have to have a web server running. And it can do the whole ball of wax in one file. To me, that's pretty cool. Coding it, unlike most compiled languages like Java and C#, the syntax for Go is pretty succinct. It's different than JavaScript or Python, but it's real short. You know, if you type, how many of you are Java coders? I know we've got a few Java coders, and probably C# as well. You know, there's quite a bit of verbiage involved with those languages. Well, Go has a lot less verbiage, so you can get a lot done in a lot less code. It's also high performance. It's probably in the same ballpark as Java. I don't know if it's as fast as C++, but it's still really young, and every version is getting a lot faster. It is suitable for really big projects, but because it's easy to set up and deploy it, it's great for small ones too. A couple of cool features. Go is real big on concurrency, having multiple things run at the same time, and the way they do it is really nice. This thing called Go routines is kind of like a thread. So every time, say, a HTTP request comes in, it fires it up on its own thread, or not thread, but a Go routine, and it runs. The big advantage of that is, like in Node.js, you don't have blocking I/O. No, that makes sense. No, need something to some of you. But the way Node.js does it, it uses callbacks. So you have to say when the I/O happens, here's where I want you to come back to. In Go, you don't use callbacks. You just the code stops running, waits for the I/O to happen, it gets the data, and then it goes on. But because each request is on its own Go routine, they don't block each other. So they're all can just keep on running. That one request will stop, but all the other ones just keep on going. So I think, and you don't have to deal with the callback issues. Channels are a way for Go routines to interact with each other. So for example, is trace, what I do in one of my projects, I want to write information to a file, like a log file as the program's running, just so I can see where it's running as it's going. And what I've done is I've started on a Go routine that all it does is it looks on a channel for something to pop up on that channel. And when it sees it, it writes it to a log file. So the main Go routine, all it does is stick something on that channel, and it just keeps on going. The other Go routine sees it show up, and then it writes it out to the file. So that's you can do a lot with channels, but that's one way that I'm using them.
For channels like queues, is it durable?
You can queue up, say, that channel if you're pushing a whole lot of things to it, and the receiver on their side can't keep up with it. You can tell it how many you want to queue up. You can say queue 0. If you queue 0, then the one that sends the message will wait until the other one gets through with it. Or you can say queue 10,000. And until 10,000 are queued up, it'll just keep going and going. So a queue is kind of a part of it. Also, the standard library that comes with it, it's got
On restarts though, is it durable? So if your machine restarted and you had 1,000 queued up, would it be trash? Or when it comes back up, would they still be for the channel?
It's a good question. You'd probably need some kind of graceful shutdown.
I was just wondering how you
I don't know. I hadn't really thought about that part of it.
Might be part of your program to set that up, unless it's got
That would
built
be
in OS.
something definitely you have to do a little research on how that application is done.
Because in that case, if you want it durable, then you do something like advanced message queuing protocol, RabbitMQ or something like that.
Yeah, I'm not familiar with that, but possibly.
I was just wondering how channels are really working.
And I will say, it sounds like it would be kind of complicated to use Go routines and channels, but the way you code it, they're really simple. The syntax is real obvious and real simple. Plus the standard library has got like bukus and stuff in there, especially web service kinds of functionality. Nothing perfect. If you're primarily coming from JavaScript or Python or Ruby or something like that, some aspects of Go probably won't look you won't be real comfortable, particularly the idea of pointers. How many of you mess with pointers when you read code? So if you know what a pointer is, you're kind of used to seeing them. I will say the way Go uses pointers, it's very simplistic though. It's not hard to catch on to it. But it is different than a lot of other languages. I think the first day that I worked with Go, at the end of the day, I said, I don't like it. It's too funky or something. Then I made myself kind of work on it a few more days. And after about a week of messing with it, I was like, dang, I really like it. This is not cool. So if you don't like it the first day, I'd say still give it a chance. Okay, here's a little sample Go program. This is the whole program. It's basically 6 lines of code. This will create a web server. And if you start that up on your PC, go to your browser, go to localhost / put like Halloween.html. It's going to look in the public subfolder. If it finds a Halloween.html, it's going to return it to your browser. So it's like a simple. So that functionality is almost built into the system, and it's real easy to engage it. Of course, if you're going to write a web service and you want to put custom logic, you can have the web server, the file server, the page before this work, and also add these custom route handlers to it as well. So that first line up there, the HTTP handle pillow, I could put that first line anywhere above the listen and serve line. I want to keep everything else I've got there and just add that one line, like right above listen and serve, but keep the other one, and I'd have a file server and a web service both. So what happens is if the URL came in with started with /hello, it would invoke the hello handler of that function. Every handler function gets 2 parameters. One's a response writer and one is a pointer to the request. The little star there just means it's a pointer. The variable name is W for the response writer and R for the request. And so then you've got full access to the request. You can look at anything about the request, do your logic in there, and then send the response back out to the response writer.
What are the similarities between this and Swift?
I did not know Swift. I don't think Swift does any server side. Isn't it all device side? No, you can do server side with Swift. Okay, I'm not familiar with that. Go does run on Windows, Linux, OS X. They're starting to get pieces of it running on Android, but they're not saying the whole thing's going to be supported on Android. So it runs just about everywhere. Anyway, the main website is golang.org. There's a lot of good documentation connected to that website. I don't know anybody else that's using it. If you poke around in it and you want to kind of get going with it and you have some questions, I mean, feel free to shoot me an email. And I'd love to have somebody else just to, trade ideas with. Anyway, I like it. I've got a project now. It's up to about 1,000 lines on the Go side of it. And the more I use it, the more I like it. Any questions? All right.
About compiling, so you can put this, you said that it goes into an exe. How is the compiling part of this? So you can compile it on Windows and on Linux also.
Right now, I'm keeping my source code on both environments and compiling in both places.
Okay.
I believe I can set it up on Windows to create a Linux executable on my Windows, but I haven't even gone through the process to really figure out how to do that. I think that is an option.
From what I understand, I don't think it really matters because the Go code compiles directly to the chip architecture. So even if you compile it on one OS, you can just drop the executable to different systems.
No, it does have to. When it compiles, there's some environment variables that tell it the target operating system and processor. You can compile it for an ARM processor if you want, or Linux, for Linux ARM or Windows x86. But it has to target one of those